Thank you very much. Good afternoon, everyone. This morning's session in this room focused largely on the destruction of organic contaminants. I'm going to introduce a new slide. And looking at sequestering inorganic species as well as destroying organic species in contaminated soil using ViroSoil technology. The presentation will include a few areas, a quick overview of brownfield site profiles, which I don't need to go into in a lot of detail, and then some reference to some of the types and levels of inorganic species and types and levels of organic species, a quick overview of what ViroSoil technology is and how it sequesters inorganic and destroys organic species, and also some of the modelling components. And then I will look at, I think this morning most of the case studies, each presentation had one or two case studies and went into them in a lot of detail. I'm going to look today at 6 case studies and really just look at outcomes rather than processes. So brownfield sites everyone is familiar with, typically refer to large-scale industrial sites, often derelict manufacturing sites, for example, but also can include smaller sites. For example, in residential neighbourhoods such as former dry cleaning facilities, and gasworks, which was the topic of this morning's session. By definition, the term brownfield site makes reference to a site being suitable for commercial or residential reuse, and so the need to properly assess, monitor and treat the contaminants commonly present at such sites is vital to modern and sustainable urban environments, because many of these sites are considerably and heavily contaminated. So some of the types and levels of inorganic species at brownfield sites, typically we're talking about heavy metals including arsenic, which is a metalloid, lead, mercury, selenium and zinc, along with asbestos, which are routinely present. The risks of asbestos and lead are very well known and well documented, but many other heavy metals are also toxic to humans, animals and the environment. And I'm just giving one example here, selenium, which doesn't show up so often because Australia geologically is selenium deficient, but it does show up from time to time. But regulators and scientists generally don't consider its presence as being all that significant. However, selenium is important and is considered important by some regulatory authorities because of these characteristics. Typically from longer-term chronic exposure, but nevertheless exposure which can result in selenosis, and long-term exposure to airborne selenium, which is a problem at some brownfield sites where dust is an issue, can cause significant health problems. At brownfield sites, total metals may be present in the thousands of parts per million and may constitute up to 1% of the soil matrix. But not only is the total or the presence of total metals a problem, the total volume or weight of metals, but also because of its leachability. When metals are when they leach from soil under acidifying or reducing conditions, they become soluble, mobile and bioavailable. Solubility and mobility of metals can lead to downstream pollution, and bioavailability can lead to uptake by plants, animals and ultimately humans. Some of the types and levels of organic species, many of these, or I guess most of these broad categories were discussed in some detail this morning in relation to gasworks, although they do appear at a whole variety of different industrial sites, including manufacturing sites. And there are hundreds, literally. Typically about 10 or 15 of them are measured or analysed for, but there are many, many more that go unnoticed. But the broad categories are the single bonded alkanic hydrocarbons, of which benzene is an example, double-bonded chlorinated hydrocarbons, of which TCE and PCE are examples, neither of which exist naturally in the environment. They are man-made contaminants. And then PAH, which was a topic or a contaminant that was discussed in great detail this morning. Organic pollutants at brownfield sites, which are relatively stable in the ground, such as BAP, pose enormous problems to humans and the environment once liberated, once dug up. For example, benzene causes a variety of illnesses, including that list there, which is not all that enticing, and in fact was recently found in a whole range of different soft drinks. Beyond serious effects to the central nervous system, workplace exposure to TCE, trichloroethylene, has been associated with toxic effects in the liver and kidney, and BAP, which is found in tobacco smoke as well as overcooked barbecued meat, which is a cause for some concern, and fried chicken, is a known carcinogen. Organic pollutants can be found in contaminated soils at low levels, typically less than 400, I'm saying they're 100, but can be 200 or 300 parts per million, to extremely high levels for total petroleum hydrocarbons in the 100,000 to 300,000 or 10 to 30% range. The recommended level of benzene in drinking water is less than 1 part per billion, and 5 parts per billion, that's in Australia, and 5 in America. The immediate danger to life, to put that into perspective, is 500 parts per billion, but is often found at levels greater than 10 parts per billion in groundwater, and an average smoker inhales about 1.8 milligrams of benzene per day, or 10 times the amount of a non-smoker. So now a quick summary of what ViroSoil technology does to these organic and inorganic species. It's used in large-scale brownfield site remediation projects, and has been deployed at decommissioned paper mills, disused manufacturing sites, oil refineries, and a former General Motors Holden site. At the decommissioned paper mill, I should mention that the levels of, for example, inorganic species can be not insignificant. At one we did last year, there was actually flowing liquid elemental mercury present in the soil. So you could see mercury actually flowing in drips throughout the soil. So, quite significant and problematic levels. ViroSoil technology uses proprietary chemical and biological reagents, in this case ViroBind and ViroBac reagents, to treat soil which is contaminated with either or both inorganic and organic polluting species, and they're often found together. Reagents are directly mixed with or injected into the soil profile. In ViroSoil technology, inorganic species are sequestered or bound into the soil matrix by the reagent, into the solid reagent matrix, and not readily re-released by acidification. And the longer the inorganic contaminant is sequestered into the reagent, the more tightly bound it becomes, with less metals being leachable the longer time passes, which is the reverse typically of most chemical additives, where over time greater or higher amounts of metals are leachable. Organic species are destroyed by oxidizing or biological reactions, and ViroSoil technology uses rapid sequestrodegradation to reduce the time it takes for reactions to occur. The process also completely destroys objectionable odours which emanate from excavated soil, and we saw examples of those also at Gasworks this morning. And some of the stoichiometric factors which we consider when profiling a site and considering soil treatment include these: concentration of contaminants, concentration of contaminants in the soil and in the groundwater, the porosity of the soil, the volume of soil and water to be treated, the total actual acidity, typically measured by pH, but also the total potential acidity, that is the total acidifying agents or compounds in the soil that could produce acidity over the long term, reagent scavenging reactions, confidence factors related to the contaminants, the lithology, hydrogeology, etc., and total reagent volume to be applied. And now 6 case studies, starting with the sequestering of inorganic species, the first one at a former cannery site, actually a pineapple cannery in Townsville. And you can see there the pH, the leachable copper, lead and selenium prior to treatment and after treatment with the treatment targets. The leachable lead was probably the biggest problem here with a treatment target of 0.1 but actually 10 parts per million, and after treatment was at 0.04 parts per million. And this was an in situ, I should say an ex situ treatment on site and then disposed of. So the soil was excavated, treated on site and then disposed off site. A second example of sequestering inorganic species, this time at an abandoned timber mill in Rockhampton, actually outside of Rockhampton. And you can see there the typical profile for copper chrome arsenate on the left-hand side, here represented as arsenic. These are the totals before. I don't have leachables before, but they're obviously less than those numbers. And the allowable leachable metals to the right, and leachable metals after addition. This too was an on-site treatment with off-site disposal. So what you're seeing here is the total metals on the left-hand side being sequestered into the ViroBind reagent, and then the soil with the reagent and the metals bound to the reagent re-leached using TCLP, and then those results represented under leachable metals. So case study number 3, destroying organic species, this one at an abandoned manufacturing site in Adelaide. This was for PCE contamination. The levels were around about the 5,000 parts per million average, and the treatment target was pretty close to 0. And this is total PCE, not leachable PCE, and this is the result of 0.009 parts per million for total PCE after treatment. Case study number 4, also destroying organic species at an abandoned factory. This actually was a former Queensland rail yard in Townsville. And you can see here fairly high measures for total petroleum hydrocarbons on the left. Odour was also a problem, and while it's not completely clear from this chart, but the site is here, and this is the main street of Townsville, so odour was a bit of an issue. It was rated from a rating of 0 to 10, a rating of 10 on the obnoxious scale. Once the soil was excavated, and after treatment was rated 0, which was the treatment target. And here, most importantly, the rapid sequestro-degradation process was used to reduce the predicted time, which was 12 to 24 months for standard land farming or bioremediation, was reduced to 6 weeks. And the results for TPH from 107,000 parts per million was reduced to 1,400 with a target of 2,000. Case study number 5, destroying organic species at an abandoned gasworks in Melbourne, BAP and PAH. This is total before, middle column, right-hand column, total for BAP and PAH after treatment. So significant reductions. And the final one, underground sludge tanks outside of Brisbane, a more complex profile of organic contaminants. This is total before treatment, 192,000 for parts per million for total petroleum hydrocarbon, and after ViroSoil technology about 6,000, and similar reductions for the other measurable contaminants. So in conclusion, we can say ViroSoil technology treats all forms of inorganic and organic contaminants at brownfield sites. I'm saying all, I've given a fairly good range here, but there are others we could talk about. ViroSoil technology uses both chemical and biological reagents. It completely eradicates obnoxious odours, and rapid sequestro-degradation, a treatment methodology used within the technology, reduces the time it takes to destroy organic pollutants from years to weeks or months.